So let's see part two, right? So part two is based on basically magnetism and magnetic matter. So this is part two of magnetism and magnetic matter. Magnetic matter. So let's see the first question. So it is asked in 2021. It is given that force formula is defined as charge into velocity into magnetic field, right? And this can be expressed in like in unit vector like VI, magnetic field in x-axis plus magnetic field in y-axis plus magnetic field in z-axis. So these are the magnetic field components in the respective three direction. So charge value is given, Q value is equal to 1 and V velocity value is 2I plus 4J plus 6K, right? And force value is given that is equal to 4I minus 20J plus 12K. Understood? And what will be the complete expression for magnetic field? It is asked. It is asked in 2021. So let's see the explanation for complete expression for magnetic field. So, so as we know, velocity and magnetic field, they are cross products. So how will you find the resultant of that? That will be given by this formula, cross product. This is called cross product. So it is given as I, J, K, and put the value of that V component that is given as 2, 4, 6. So it is given as 2, 4, 6. So you can see the velocity components. So write the coefficient of that respectively, right? And next is magnetic field component. So this is your magnetic field component, this part, right? So put here, so it will be B, B, B naught. Now we are finding as V cross B, velocity cross magnetic field, right? So for finding I unit vector, we multiply 4 into V naught minus of B into 6. So it will be 4B naught minus of 6B minus of J into. So when we consider J, then we omit this part, then multiply 2 into B naught. So it will be 2 into B naught, right? Minus of B into 6. Similarly as K, unit vector as. So for finding the K, we omit this part, right? This part we will not consider. So we'll consider only this one. So it will be 2 into B minus B into 4. So it will be 2 into B minus 4 into B. Now calculate the value. Then it will be coming out to be like I into this, solve this one. So this is 4B naught minus 6B. So let it be there only. So it will be 4B naught minus of 6B minus of J, right? This is 2B naught, right? This is 2B naught minus of 6B. So it will be remaining same only. So it will be 2B naught minus of 6B, right? Plus K. This will be the subtracted. So it will be minus of 2B, right? Now we know what we know by comparing both sides. So what we get? V cross B value, no, right? That is F value. So this value is given, right? F value. So put here F value. So it is given as 4I minus 220J, right? Plus 12K. Why I have written the value of F? Because we know F value formula is Q cross B, right? Hold for a second. So this is your F, And now equate to the components like so 4i will be equal to this value, right? So I will solve in the next page by comparing both sides. So it will be 4i is equal to how much? It is 4b naught minus of 6b of I unit vector, right? So this I and I will get cancelled. So it is equal to 4 is equal to 4b naught minus of 6b. So this will be the first equation. Now compare the second component, j component. So j will be coming out to be, so you can just see it out there. So you can see this is minus 20j and this should be equal to this quantity, right? So compare it. So it will be minus of 20j is equal to minus of j, minus of j, right? 2b naught, 2b naught minus 6b, right? So this minus and minus will get cancelled and this one quantity also get cancelled, j and j. So remaining is 20 is equal to 2b naught minus of 6b. Take 2 as common, so it will be 2b naught minus 3b is equal to 20. So it is equal to 10 equal to b naught minus of 3b, right? So this is the second equation. Now compare the j quantity. So j quantity is nothing but it is 12k is equal to minus of 2b. So it is equal to 12 equal to minus of 2k quantities, right? So k unit vector. So now cancel that one. So this k and k will get cancelled. Remaining is 12 equal to minus of 2b. So b will be coming out to be minus of 6. So now put in here in first quantity from first equation. What is 4 equal to 4b naught minus of 6b. Now put the value b into b naught minus of 6 minus of 6 equal to 4. So 4 is equal to 4b naught. This is minus minus plus 36. So 4b naught is equal to 4 minus of 36. So it will be minus of 32 4b naught. So b naught will be equal to minus 32 upon 4. So it is coming out to be minus 8 b naught. So we have calculated the value of b and b naught. Now, right. So put the value of b components. So resultant magnetic field will be coming out to be minus 6 of b minus 6i minus 6g minus of 8k. So this will be the B magnetic value. So please write it down. Very important question. Now look at the second sum. A wire of length L meter, right? Carrying a current I. So this is your wire having length L, right? And carrying a current I flowing through it is bent in the form of circular. So after this straight line, they are bent in a circular path like this. So its circumference is 2 pi r and 2 pi r equal to will be the length of this length of the wire. So magnetic field moment you have to tell. So let's see. So remember this formula, basic formula. Magnetic moment formula is magnetic moment is equal to current into area. So it is I into A. Current into area, right? So as we know, the area of circle, it is given by pi r square. So put here value. So it will be pi r square, right? So what will be the r value from this equation? From here you can find r. So r will be length upon 2 pi. So put here. So it will be I into pi. R value we know L upon 2 pi is whole square. right? So calculate it, then you will get the magnetic moment. So it will be I into pi into L square upon 4 pi square. So this is the magnetic moment of this circular, and unit is ampere per meter square, ampere meter square. So write it down. So it is, this question is asked in 2020. Now see the third sum. Third sum is talking about bar magnet is hanged by a thin cotton thread. Suppose this is a rod, iron rod. This is hanged by a thin rod in uniform horizontal magnetic field. So it is hanged in uniform magnetic field and is in equilibrium state. The energy required to rotate it by, so you have to just rotate this hanging by 60 degree, right? So energy required is W. So energy is given by W. Now the torque required to keep the magnet in this position. So new position, how much torque is required? It is asked in 2016 AIPMT. So let's see the third. So torque on magnet is given by. So this is the basic formula. You have to just remember it. So torque symbol is tau. It is also called as tau. Tau. It is represented by magnetic field into magnetic moment into sine of theta, right? And this is the first formula. Second formula is work. Work means energy. Energy formula. So energy formula will be, it is magnetic moment into B into cos theta 1 minus of cos theta 2, right? Cos theta 2. So now put the value. So after putting value, you will get the energy value. So it is MB. Initial angle is 0 degree. So I'll put here cos of 0 minus of. So it is rotated to the 60 degrees. So it will be cos of 60 degree, right? So now put the value. So it is MB. Cos 0 is 1 minus of cos 60. So cos 60 is 1 upon 2. Now take the LCM. MB, it will be 2 minus 1 upon 2. So it will be MB upon 2, right? 2 minus 1 is 1. So it is, answer is MB by 2, right? So what we are getting? So this is your work value. So cross multiply to this. So it will be 2W is equal to MB. This is the final answer, relation between magnetic moment and this energy, right? So now see, now I will calculate the torque. So torque we know that is MB of sine theta. So sine theta we know sine of 60. So sine 60 is nothing but it is root 3 by 2. Now MB from this equation, third equation, MB value is that is equal to 2W. So put here 2W into root 3 by 2. This 2 and 2 will get cancelled. So you are getting torque as how much? It is root 3 into W, right? So this will be the exact value between the torque and energy. Torque is nothing but it is force. When it is rotated, it is converted into torque, right? So torque is also called as force into distance, displacement. So remember this formula also. Calculate it. Now look at the question number 4. So following figures show the arrangement of bar magnet in different configurations. Each magnet has magnetic dipole moment M, which configuration has highest net dipole moment. So there are 4 gram given. You can see in the option. So see the explanation. So as we know the magnetic moment, net magnetic moment formula. So I will write it down for you. So it will be given by M1 square plus M2 square plus 2 M1 M2 cos theta, right? So we know the maximum value of cos theta is nothing but it is 1. So cos theta comes when 1? It comes when angle is 0, right? So angle should be 0. So you can just observe it in the option 4, they are given angle is 30, right? So that will be the maximum value. And we know cos 30 is nothing but it is given as root 3 by 2. So if angle theta between two vector increases, then the resultant vector decreases, right? So it is a square root. So when angle increases, magnetic field decreases, na? Because they are taking a square root. So maximum when theta is minimum. So when is the magnetic needle will be the maximum? When angle is less. Angle means theta. Angle will be less, right? So C option, it is matching. So its diagram is given like this. This is your south pole, this is north pole, and this diagram is made like this. So angle between them is 30°. It is asked in AIPMT 2014. Let's see the question number 5. A bar magnet of length is given, that is L, magnetic dipole moment M, right? So bar magnet whose length is given, that is L, and magnetic dipole moment is given, that is equal to capital N, is bent in the form of arc. So it is bent like this. You can see on the diagram also, right? This is angle 60°. This is length L, right? It is asked in AIPMT 2013. So let's see about it. So magnetic dipole having a strength M is given as, so magnetic dipole will be given as M into L, right? So L is nothing but it is, this is your circular path, right? This is making angle of 60°. So total angle we know that is 360, right? So 360, it is covering only 60. So 300 are remaining, right? So it is coming out to be length as pi into theta. So it will be pi by 3. 60° is converted into pi by 3 into r. So how you convert 60°? So you should multiply with pi upon 180 to convert into radian. So we are converting this angle theta into radian. So this sign is called radian. And when we put dot here, then it is called as degree, right? So this 0 and 0 will get cancelled, and 6 will divide this 3, 18. So it will be pi by 3 is equal to 30, right? Now we know the further magnetic moment coming out to be m into 2r sine of 60° by 2. So this 2 and 2 will get cancelled. And as we know, sine of 60° is nothing but it is root 3 by 2. So we are dividing this angle. So it is sine of 30. So sine of 30 is nothing but it is 1 upon 2. So your answer will be this is 1. So 2 and 2 get cancelled. So it will be remaining MR only. So you can find the relation between them. So your M dash has come out to be, it is small m into r. And originally MR we know that is nothing but MR pi upon 3. Right. Now find the relation between these two. So how will you get that? So here MR is there, right? Instead of MR, what we can put from here? So cross multiplies this 3 with this capital M. So 3 into capital M equal to divided by pi here, then it is remaining to r mr. This consider the set third equation. Now put this third into second. So it will be m dash is equal to, instead of mr, we will put 3m upon pi. So it will be 3 capital M upon pi m dash. Right. So this is the answer for that. Done. Now see the question number 6. A magnetic needle suspended parallel to the magnetic field required 3 joule of work. Right. So how much joule is required? It is 3 joule. To turn it through 60 degree, right? Magnetic needle is there. So which is suspended perpendicularly or parallelly to the magnetic field. This is parallel magnetic field. Right. Parallel magnetic field. This is your bar magnet. Torque needed to maintain the needle in this position. So we have to find the torque. Torque is nothing but it is F cross R, force into displacement. So let's see about it. So as we know work formula in the previous question, we have also given you. So it is nothing but it is given by W is equal to MB, right? Into cos of theta 1 minus of cos theta 2. So please remember this formula, very important for your examination point of view. So how will you calculate? Work value is given, that is 3 joule, right? So it is 3, no, not 3, it is root 3 joule. So put here root 3 and MB value we don't know. So initial angle we know that is 0 degree and it is rotated to be the 60 degree, right? So now calculate it. So you will get cos 0 we know that is 1. Cos 60 is nothing but it is 1 upon 2. So finally you are getting MV by 2 is equal to root of 3. Right. So MB will be how much? These 2 will be multiplied here. So MB will be getting as 2 root of 3. Right. So as we know torque formula, right? That is given by formula. Initially I have given you in the magnetic field, right? Torque is nothing but it is MB sine of theta. So it is, now put this MB value here from this equation first in the second. So it is 2 root of 3 and sine we have no, that is 60 degree. So sine 60 is nothing but it is root 3 by 2, right? So this root 3, 2 and 2 will get cancelled and root 3 and root 3 multiplication getting as 3. So torque we have got as 3, right? So this is the torque value, 3 joule we are getting. So please write it down. Now look at the question number 7. 7, a short bar magnet of magnetic moment is given. So magnetic moment of this short bar magnet is given. So it is given at 0.4 joule per Tesla. Is placed in uniform magnetic field. So whose magnetic field is given by B, magnetic field. It is nothing but it is 0.16 Tesla. The magnet is a stable equilibrium when position energy is. So how, when it is stable? It is asked in 2020-11. Yeah, for stability, energy should be is equal to magnitude of MB, right? So put the value, M value we know. This is your M value and this is your B value. Put here in the second equation, given data. So it is coming out to be minus of 0.4 joule per Tesla into B value is 0.16 T. So this and T get cancelled. So your energy coming out to be 0.4 into 0.6. So it is nothing but it is coming out to be 0.064 joule, right? This U means energy. Energy symbol is U, and it is also given by W. Sometimes it is written as potential energy, sometimes it is kinetic energy. All these meaning is same, right? So please write it down.